Okay, now we are going to do example 10.2. This example is for far end pin. Example 10.1 is for far end fix. Okay. Example 10.2, and the question asks us to draw shear and moment diagram. Okay. We have one beam like this, where A is fixed and C is roller. We also have B roller. We have distributed load triangle shape for span AB. (40 kilonewton per meter, and 1 point load between B and C, 60 kilonewton. The length from A to B is 6 meter and B to C 2 meters. Okay, so we need to know what is support reaction at A, which is AY, MA, AX, BY, CY. Once we know all the support reaction, then we can draw shear and moment diagram. Okay, how to calculate all the support reactions? We need to use the slope deflection equation. Okay, first we are going to analyze span AB. Then after that, we are going to analyze span BC. Before we start analyzing, we need to draw the deflected shape of the beam. Okay, 40 kilonewton here. Push the span AB and the deflected shape will be like this. This is fixed, so no theta. Here we have roller at B. Then see like that. So we have here theta B and also theta C. Here no theta. Okay, so I put it as 0. Okay. To analyze this structure, this is fixed, roller and roller. Once you want to analyze span AB, we need to assume the middle cutting section is fixed. So it become like this. Span AB. A, B, then here we have MAB, here we have MBA, then we have distributed load, (40 kilonewton per meter). Okay, don't forget we also have here theta B. This one is 0, like this. Okay. Okay, for span AB, we are going to use the slope deflection equation for far and fixed. Just like I mentioned before, we need to assume here fixed because this is in the middle. Okay, for span BC, this is fixed, this is roller. So we are going to use the far and pin equation. Far and fixed equation for NP equation. Okay, just imagine this one here fixed. Okay. Okay, this span AB fixed. So for n fixed equation is Mn is equal to 2e, the same equation like example 10.1 ya. 2 theta n plus theta f minus 3 psi plus f e m n. Okay, this is for n fixed equation. Fixed. Okay, then calculate MAB here. So MAB is equal to 2e I over length 6 meter to theta n 0 plus theta f theta b, because we are analyzing at this point, so our near is 0 and our far is theta b, minus 3 psi is 0 because point A and point B no displacement, so 0. Then FEM for span AB. Okay, so you need to find what is FEM for span AB. Okay, plus FEMN. Okay, what is FEM for span AB? I will show you how to get the FEM. Actually, we need to find the FEM first. So, that's okay. We just proceed. Okay, for span AB, FEM AB, FEM BA. Okay, I draw it one more time. MAB, MBA. 6 meters. This one is 40 kilonewton per meter. So I ask you to assume that this is fixed and here is fixed. This one is fixed, but this one you assume to be fixed. Okay, how to find FEMAB? This side. Okay, refer to the table, this table. Okay, as you can see, we are going to use this one. Okay, fix, and we have triangle shape of distributed load. Sorry, rectangular shape of distributed load. FEM AB, FEM BA for this one, same. Okay. This one. Okay, for this side you refer to this one, which is WL square over 12 and FEM BA is equal to, here, same, WL square over 12. Okay, now look for the arrow. Okay, this side you assume the MAB will be like this. So refer to this one, which is this way. So your FEMAB will be negative because different arrow with this one. Okay, this one is like this and also same like this. So this one should be positive. Okay. Now we continue. So we have W is 40, length is 6/12. So FEMAB minus 120 kilonewton dot meter. So FEMBA same but positive. So we have positive 120 kilonewton dot meter. We have FEMAB, FEMBA, then plug in back this equation. Okay, MAB 2E I over 6. This one 0. So we have theta B FENAB minus 120 kilonewton dot meter. So we have MAB is equal to 263 0.3333 E I theta B minus 120. This is equation number 1. Okay. Now we are going to proceed for MBA. Okay. MBA is equal to 2E I over 6 2, we are here. So theta near, theta n is 2 theta B plus theta far 0 minus 3 0 plus FEMBA 120. So your MBA here 0.667 EI theta B plus 120. This is equation number 2. Okay. Settle for span AB. Next, we are going to analyze span BC. Okay, you have your equation 1, equation 2. Now for span BC, here, meter. C is roller, so no moment, only have theta. See theta B here, theta C here. We have 60 kilonewton, and this one you assume to be fixed because it is in the middle, right? Okay. Okay, for this kind of span, you are going to use far and pin equation. Okay, what is the equation? MN is equal to 3E I over L theta n minus psi plus FEMN. You can find this equation in the slide. I have shown you in the slide. Okay. We have here MBC Okay, I will put ni MAB. So we have MBA and we have MBC. This one no moment. Okay, moment AB, moment BA, moment BC, roller no moment. Okay, this one we cut and assume as fixed, so we got moment. Okay, so for this one, for NP equation, we only have one MBC, then MBC, so use this equation, 3E I over 2 theta n, because we're analyzing at this point, so MBC, theta n should be theta B. This is near, this is far, so theta B minus psi is 0 minus FEM for this span. Okay, BC lah, span BC. Okay, how to find FEM BC? Use this table. So we have, which one is similar? So we have this one similar to this span. We have fixed, we have roller, we have point load in the middle. So FEM AB here is 3PL over 16, but our case is BC, span BC. So FEM BC is equal to this one, 3PL over 16. But if you can see, the one that you assume is this arrow, but here is this arrow, so should be negative. Contradict from the table. You assume this side, but the table positive is this value, so you put negative. Okay, is equal to negative 3. P is 60. L is 2, length, divide by 16. This one is equal to minus 22.5 kilonewton meter. You have your FEM here, then you plug in this one. So you have MBC is equal to 3 over 2, 1.5 EI theta B FEM minus 22.5 kilonewton meter. Okay, this is equation number 3. Okay, let's see equation number 1. Sorry. Okay, we have equation number 1, equation number 2, and now we have equation number 3. Okay, so the fourth equation, as you can see here, we have 4 unknowns, 1 unknowns, 2 unknowns, 3, 4. So we need to have one more equation. The fourth equation is going to be here, same like example 10.1. The fourth equation is going to be at point B. Let me show you. This is point B. BY. Okay. So point B here. So we have MBA, MBC. Okay. We do summation moment at B, then we have MBA plus MBC is equal to 0. So this is equation number 4. Okay, you have MBA, you have MBC is equal to 0. Now we are going to plug in we are going to plug in MBA, this one, MBC, this one, into this equation. MBA plus MBC is equal to 0. What is MBA? MBA is equation number 2. So we have 0.667 EI theta B plus 120 plus MBC. So your MBC is plus 1.5 EI theta B minus 22.5 is equal to 0. Then you solve this equation, you will have your theta B is equal to 45 minus 45 EI. Okay, you have theta B, then you substitute this theta B in equation number 1, equation number 2, equation number 3. You will have MAB is equal to minus 135 kilonewton meter. MBA is equal 90 kilonewton dot meter. MBC is equal to minus 90 kilonewton dot meter. Okay, you have your theta B. You start substitute 45 over EI here, here, and also here. Then you will have your moment value like this. Okay, you have all the moments that we are going to use for the next calculation. Okay, as you can see, we have negative, positive, negative. What does it mean by this value? Is negative here means, okay, can you see? You assume MAB to be this arrow. Okay, if negative 135 you got at your last in your calculation, meaning that your sign is contradict with what you assume, meaning that MAB is this arrow. Okay, so MBA you assume to be like this, you got positive, so it is right, like positive 90. So MBC you assume to be like this, you got negative, so you just change the arrow of your moment. Okay, you have this value, and this value. Now we are going to calculate support reaction. Okay, so we write back again here. So you got MAB 135. Okay, you assume to be this sign, but you have not minus, so the right sign is this one, so you have 135. And MBA you got 90, so MBA is 90, and MBC here is minus 90, so MBC should be this way. MBC is equal to 90. Okay. Next, we are going to calculate the support reaction for A, B, and C. How to do? How to calculate? Okay, like this. Okay. separate the span. Okay, calculate separation. Span AB. A, B. Okay, don't forget you have here, you got from your calculation 135 kilonewton dot meter, and here 90 kilonewton dot meter. This is MBA, ni MAB. Okay. Then we have 40 kilonewton per meter, rectangular. So change to point load, 40 multiplied by 6, 240 kilonewton, 3 meters. Okay, you have here AY, and here BYL. L is left. Okay, 6 meters. Calculate your BY. You will do summation moment at A. Okay, summation moment at A. So we have 135 plus 135 minus 90. Okay, minus 240 multiplied by 3 meters. You have here plus BYL multiplied by 6 is equal to 0. So your BYL is equal to 112.5 kilonewton. Okay. So your AY is equal to 240 minus 112.5. You have 127.5 kilonewton. Okay. So you have AY 127.5 and BY 112.5. Next, span BC. Okay. You have here B wire, right? And here you have CY. Here, CY. Then you have 60 kilonewton in the middle. Don't forget the MBC that you got from your calculation. 90 kilonewton meter. Okay. Do summation moment at B. So you have here 2 meters. You have plus 90 minus 60 multiplied by 1 minus CY multiplied by 2 is equal to 0. Then we have CY is equal to 15 kilonewton. So BYR is equal to 75 kilonewton. Okay. Now you have AY, BY, and CY, BY. Okay. BYR is equal to 75. CY is equal to 15. Now we draw again to do the moment here and moment diagram. Combine span B and span C, span AB and span BC. Okay. again. So we have AY 127.5. BY left we have 112.5. BY right we have 75. So this one plus this one, because this one is upwards. BY right also upwards. Then we have BY is equal to 112.5 75 187. CY we have 15. MAB here 135. Okay, this one okay, MBA and MBC, if you add these two will become 0, so I don't put any moment here. So we have MBA 90, MBC minus 90, so 0. Okay. Okay. Have everything. Then we are going to draw shear diagram. Shear kilonewton x. Okay. Now we start with shear. We have 127.5 upwards. Okay. So you don't want to know what this point, what the value of this point. So 127.5 minus 40 multiplied by 6, because this is 6 meters. Okay, this value is 40 minus 127.5 minus 40 multiplied by 6 sama dengan, so you have minus 112.5. Okay. Okay. Then you have plus 187.5. You got 75. Go up here. Okay, 112.5 minus here plus this value, and you will have this value. Then you go straight. Don't forget you have okay 75 straight, then minus 60. 75 minus 60, then you will have 15. So straight, then you have 15 down, so 0. Okay, calculate the area here. Okay, first you calculate this area. This one is 1 meter. 1 meter, so this one is 15. The area here, 15 multiplied by 1, 15. 75 multiply by 1, 75 area. So you need to know, next you need to know this length. How to know this length is 127.5 minus 40 multiplied by x is equal to 0.0 here. So your x is equal to 3.1875 meter. So this length 3.1875 and this length is 2.8125. Okay, calculate this area. 127.5 multiplied by 3.1875 divide by 2, you have 203.2, and you calculate this area. 2.8125 multiplied by this length, which is 112.5, then divide by 2, 158.2. Minus, because this area is negative section. Okay, then you can proceed with your moment diagram. Got all the area. Okay, start with 135 moment here. Minus 135. Okay, then repeat here. What is the value at this line? Minus 135 plus this area. Minus 135 plus 203.2. Then you will have 68.2. Okay, 68.2 minus 158.2. You got minus 90. Okay, minus 90 plus 75, you will have 15. Minus 15. Minus 15 plus 15, you will have 0. Okay, so this is your moment diagram. Moment kilonewton dot meter. Okay, this is the answer for example 10.2.